Imagine, how could you make your business more intelligent using data? Where do the digital customers using your services come from? How can you engage them better and improve customer churn? How would discounts affect your inventory and margins? Imagine if you could use data to analyze these questions and intelligently predict outcomes. But each question could take hours, maybe even days, requiring more servers than you have in any on-premise data center. But now, you can use Azure to add unlimited compute power to your questions. Introducing SQL Data Warehouse. The new SQL Data Warehouse service is easy to create and can be launched in minutes. It's the industry's first cloud data warehouse that can grow or shrink to any size in seconds, and which you can use to intelligently answer any question using data. You can easily import data from any data source, with automated data pipelines from Hadoop, NoSQL, and SQL databases, IoT, as well as on-premise applications and systems. Then you can easily create reports against it, as well as visualize it. Simply connect Microsoft Power BI to a SQL data warehouse in just seconds. It also unlocks the ability to easily use predictive analytics. Azure Machine Learning can now use petabyte-scale data, with applications written in R and Python to analyze customer product recommendations or assess customer churn risk. You can expose machine learning APIs that your apps can call to more intelligently interact with your customers. A data warehouse that can scale up in seconds enables Power BI and Azure Machine Learning to tap into unlimited query power. So you can visualize and explore unlimited scenarios. The power to use data to build intelligent apps has never been greater.
Thank you and welcome. So we're going to go through the Azure SQL Data Warehouse today. I'm Matthew Winter. I'm one of the Big Data Global Technology Specialists based out of Australia, covering the Australia and New Zealand region. So let me introduce the SQL Data Warehouse. Essentially, the Azure SQL Data Warehouse, it's a fully managed relational data warehouse service managed by Microsoft. You don't have to worry about patching, you don't have to worry about upgrades. This is all done for you by Microsoft as part of the service itself. It is the first elastic cloud data warehouse. It has enterprise-grade capabilities, and we're going to dig into this throughout this presentation. And we recommend the sweet spot for beginning with a SQL data warehouse is 250 gigabytes in size, all the way up to a petabyte in size, all within an Azure data center. Now today, we have it live as a preview within 17 data centers out of the 19 within the world that we have. So today, I'll be demonstrating it from the Melbourne data center, so it is available for you to access from New Zealand. So essentially, how many people here know Parallel Data Warehouse? There's a couple. APS? The alternative name? So we have one. So for the past 5 or 6 years, we've been selling APS, or the Parallel Data Warehouse appliance, for on-premise use. That was our first go at MPP technology. We've used the same code base here within the Azure SQL Data Warehouse. So it's no longer SMP based, i.e. you're limited to a single system or a single virtual machine. We can scale across multiple compute nodes. And within this particular current preview, we can scale from 1 compute node all the way out to 60 compute nodes. As we say, this is totally powered by the Azure cloud. We're not doing anything special. Our competitors, for example, will be dropping in hardware into their data center. We are using the same technology that you can use today within the Azure cloud. We've just built this service on top of that fabric. And of course, this is Microsoft, it is Azure. We want to make sure that this is a leading price, and we've already gone out to our customers, and we believe that this is, without a doubt, the current best price that you can get for actually starting out a scalable data warehouse within the cloud. And we will cover some of that. So let's begin at looking at the scalability of the system. So I mentioned previously that this is MPP-based, or massively parallel processing. What I didn't mention is that this is a complete separation between compute and storage. Today, if you look at SQL Server, those tend to be co-located, and you can't separate the two in terms of where they are executed. With the Azure SQL Data Warehouse, we actually separate the storage from the actual the compute, so you can scale out the compute without actually having to scale out the storage. This is very different to the normal appliance models that we have today in the market. And so we can start small from one and scale out as your loads your workloads require. Now, the other thing to note is we can do this in seconds, and I'm actually going to be demonstrating this on stage as well. So you can scale out in seconds. So if your peak workload for a data warehouse is at say a weekly or monthly or quarterly basis, you can scale up at that point, use the extra performance, and then scale back down, save money, but still use the rest for the rest of the day. Now, the way we actually do that, we've got a couple of methods. One is via the Azure portal itself. It literally is as easy as what you saw in the video. You just increase the number of DWUs. I will explain what a DWU, or a data warehouse unit, is later. Or you could use PowerShell. We love PowerShell at Microsoft. And of course, T-SQL for those SQL developers here. And the other benefit of being able to scale out is the ability to pause. If you've got development, test environments, you don't want to be paying for that infrastructure or even that compute while you're actually not using it. So most developers, it's a 9 till 5 job. For the occasional few, it's extra. And you want to be able to turn that infrastructure off and not have to pay for that compute. We give the ability for you to pause, remove the need for actually paying for the compute, and just pay for the storage. And then when you're ready for the following day, bring that compute back up. And again, this is done in seconds. And we're the only provider, the cloud provider, that can actually offer this today. And as mentioned before, we have all the scripting capabilities. So let's actually switch over now and just actually have a look of that in action. So what we're looking at here on screen is the Azure portal. So I have an instance of the Azure SQL Data Warehouse running out of the Melbourne data center. Currently, if we click on scale, we can see that this is actually running at 500 data warehouse units. Essentially, we increase based on 100 increments, and each 100 is equivalent to a compute node today. So let's just go ahead and double this. Why not? We're in a demonstration after all. It's as easy as just slide, save, and it goes ahead and starts to scale the database. Now, I'm going to talk a little bit about what it's actually happening underneath. So today, because we actually have separated the storage from the compute, we don't have to redistribute the data. We've actually designed it so that we're actually, all the data is already distributed across what we call our maximum number of distributions. So all we're doing is relinking storage behind the covers and instantiating new VMs. It's a far faster approach than, say, some of our competitors. If we look at Amazon with Redshift, they would actually have to take hours to 24 hours just to scale out, purely because they have to redistribute all of that data. And we'll see shortly that this will actually just complete. Roughly at the moment, it's taken about 59 seconds to roughly about 69 seconds to actually do that scale out process. Now, this will improve. We're in preview. So we're improving the performance of the scale out, the pause, as we go into the GA. I'll just give it a few more seconds. There we go. Now that's actually at the point where it's now accessible. You can now query the actual database. We have twice the number of compute units available to us, and we can expect double the performance when we actually come to run those queries. So for those that don't know MPP architecture, how many of you understand massively parallel processing? I see the same hands for APS and PDW. Essentially, so SMP, or symmetrical multiprocessing, is about scaling up a single server or a single instance. So if you ever needed to be able to improve the number of compute or the amount of memory, essentially you're swapping out the actual server and putting in a much larger server. Now, yeah, technology improves over the years. We can have 240 cores now on some of the latest generations of hardware, but it's not the answer. It's not the most cost-effective answer. Massively parallel processing is because it allows you to use commodity hardware and scale out across multiple compute or servers. Essentially what we're doing is rather than me standing on stage, whatever size I am, doing all the work for you, I'm going to share the work out to everybody in the crowd and use the power of the crowd. Essentially, it's the same philosophy. And that's what the Azure SQL Data Warehouse is built on. Now, I did have a question yesterday that was specifically asking, are we increasing the I/O at the same time? The answer is yes. So as this is essentially a shared nothing architecture. As we add on new compute, we are adding CPU, memory, and I/O capacity. So you can expect the increase in the performance there as well. Now, the Azure SQL Data Warehouse is built on the foundations of SQL Database. How many of you use SQL Database today in Azure? Oh, that's much more. Okay, so SQL Database is our Azure version of SQL Server. Essentially, we've already done the work to actually make it Azure friendly. We've done all of the compliance efforts. We've got the SLA that we require for within SQL Database. And so we're just working on the top of that foundation that's already there to actually build the SQL Data Warehouse. So if you look there, all the trusted tools you've got, SQL Server Data Tools is what I'm using for the demonstration. Fully accesses the SQL Data Warehouse, gives you all the information. The compliance. Now, we have to go through the compliance again. That's standard because it is a new technology. But because we're built on this foundation, we expect that to be a very simple process. Now, the benefits of this, of course, is that we didn't have to redevelop any of that effort that was already done as part of the Azure SQL DB work. And so we were far faster to market. And so when new features come out in SQL DB, we can introduce them into SQL Data Warehouse as well. Now, what that does mean is we are limited to the same capability as what SQL DB is. So SQL DB, as many of you will know, is a subset of the SQL Server functionality. But just showing on the screen here now, we do have a wide variety of capabilities: user-defined functions, stored procedures, partitioning, collations, indexes, full clustered column store support. All of this is available within the SQL Data Warehouse. When you look at some of our competitors, they don't have half of this capability. Now, we believe that everyone in this audience will want at least these 4 pillars as part of their warehouse. Now, as well as that, one of the things we're focusing on is making sure that we have a wide variety of third-party tools that's going to work with the Azure SQL Data Warehouse. Now, we've already done a lot of work with these particular vendors, Tibco, Looker, MicroStrategy, making sure that they fully work against the Azure SQL Data Warehouse. And we are adding new third-party software vendors on a daily basis. And I got asked the question yesterday, will we have Warescape support? The answer to that is we are working with Warescape to add Warescape Red support. One of the other benefits with the Azure SQL Data Warehouse is we have Polybase today. So we're not reliant on SQL 16. Polybase has been available in the Parallel Data Warehouse code base for a number of years. That exists today. It gives us the ability to query unstructured data or actually manage that unstructured data from either Hadoop, Azure Data Lake, or Azure Storage Blobs. Now, one of the benefits of this is if you want to load data, it's as easy as writing a query, and we'll actually demonstrate this as well on stage. So simple put, Polybase, what you're actually doing is you're defining an external table. over the actual files themselves contained within HDFS or the Azure Storage Blobs. And then from then onwards, the SQL Data Warehouse Optimizer has full access to all of that information, and you can either pull that data in to join directly with the data that's contained in the warehouse, or you can use it as your ETL mechanism, or you can export out to it as well via Polybase. So it's the full round trip. Now what that means is that many of the tools today might not support, say, HD Insight, for example, but with the benefits of Polybase and the Azure SQL Data Warehouse, they can just use the Polybase feature, write normal T-SQL that they might have support today, and take advantage of data contained within Hadoop. So to actually achieve this, there's a couple of things that we would need to do, and this is just as an example. We obviously have to define all of the credentials necessary to access the Azure Storage Blobs. And it's, again, all of this is done purely in SQL. So you would create those credentials, you would put in your secret key, and from there you then define an external data source, the location of that being, say in this example, the Azure Storage Blobs. And then on top of that you define an external file format. Now, this defines what the terminators are, field terminators, date formats. You can have compressed data. It's a common requirement, really, today. You want to keep your data storage usage as low as possible, so you, say, compress that data with, for example, gzip. We can load that data directly from a gzip file. We just specify, and I'll show you this in the demonstration, the actual file format as being gzipped. It's as simple as that. And there's also benefits for actually loading data from a compressed file. There's less read, so the actual data load is faster. And once you've done that, you define an external table. So all of those, that basically gives you the structure of the data using the location, the data source, and the file format. And from this point onwards, SQL just treats this external file as another table. And so you can write any T-SQL against that external table. The other part as well is we wanted to make sure that the Azure SQL Data Warehouse is fully integrated with the entire Azure ecosystem. So we spent a lot of time making sure that Power BI and Azure SQL Data Warehouse is fully integrated. And you've seen yesterday in the Power BI demonstration, the Cortana Analytics Suite demo, that it's just available, it's just another source. And you just select that, put in your credentials, and fully access the SQL Data Warehouse. And if you didn't see that, I'd advise you to have a look online. Other areas as well, Azure Machine Learning, again, it's just another SQL source. It's because the actual the data is in the cloud, we can just specify what the actual reader is and say this is Azure SQL, put in the actual server name, credentials, and pull the data directly from the data warehouse. This gives you a lot of power and capability to use things like the machine learning that you have today to do, say, for example, data classification, next best offers, all of those kind of things, using a nice web-based tool such as the Studio. And the other question that everybody asks is, how do we get data in? What kind of integration tools do we support? So out of the gate, we fully support SSIS, as you would expect. So you can run SSIS on-premise and push data into the cloud. It will just use BCP support today. That's not the advised approach. The other approach is to use the Azure Data Factory, which gives you the ability to reach out to on-premise data, and we'll show you this in a bit later. Reach out via the data management gateway and pull the data from your on-premise system and load that into the SQL Data Warehouse. Now, all of this can be done literally via coding JSON. And it's extremely simple, and we'll show you this later. Now, let's go back a little bit to what is a data warehouse unit. So essentially, a data warehouse unit is our metric that we're using to define how much compute power that you actually have. Now, for those that know SQL DB, you'll already see that there are DB units. This is the equivalent, except what we're actually defining it, and we're not releasing these figures yet, so which is why they've actually been masked on this spreadsheet. Essentially, we're going to guarantee a level of scan rate, loading rate, table copy rate for each of those data warehouse units. What that means is as we add hardware, a new infrastructure within the Azure data center, we'll still guarantee that particular scan rate, even though it might be running on newer hardware. Now, we can, one of the things we'll do is we'll actually show roughly what the kind of performance is on the SQL data warehouse. Now, because you're paying based on data warehouse units, and you're splitting the actual storage from the actual compute, it really comes down to how do you want to price this? Do you want slow performance, which is good enough for what you need today, but with masses of data, so petabytes worth of data with 100 DWUs? You can run that. Not advisable. It wouldn't be what we call the SQL data warehouse balanced view, but it still will work. And that's the thing here. So you can define literally just by tweaking how much storage you have versus how much DWUs, what level of performance you want that's going to meet your requirements. And you can do that dynamically. So as I said previously, if you have those peaks and troughs, there's no need to size this based on the peak. Just increase it when you need it. Any questions? So let's go in and take a look at the demo. So what I have here, this is just a simple script. I'm defining an external table. I'm looking at a particular location. This example here is actually a gzip file. I have some Azure storage data that's stored within the Melbourne data center. In fact, if I quickly go across to here, we can see all the data that I have available to load via Polybase just within the container. And the one that we'll be loading today is the direct marketing. I can see it. There it is at the bottom. Direct marketing text gzip file. Now we can open that from the Azure storage blobs directly and just look at the data, but the quickest option is just to go ahead and load it and view the data itself. So I've already created the external table. I've already defined the gzip delimited text file. The next step really is to actually load that data into the SQL data warehouse itself. And we do that via what we call a create table as select statement. Now that's different to SQL Server. In SQL Server you would probably use select into, but this is the equivalent within APS and SQL Data Warehouse. Now the benefit here is you can define at the top, within the with clause, how that table is actually going to be distributed. Now in this example, it's using round robin. And essentially what round robin does is guarantee an even distribution across all compute nodes. Now the other option is to hash distribute it based on a particular column. Now if you were designing this as a proper data warehouse, I would advise the second approach rather than use round robin. Round robin is ideal as a staging table because you can guarantee that level of performance as you query on the top of it. But the actual final table set really should be hash distributed. And there are benefits to that, and we can go through some of that. But essentially, in addition to this, I can define whether or not this table is, in this example, it's a heap table. I could also add on there clustered column store index, and that will become a clustered column store table. I can, or a clustered index, define what that is, or the partitioning directly from within there, and it will automatically define all of those. You no longer need to actually define your partition schema, partition functions, and those kind of things. All of that's done for you by the system. All you say is, I want to partition the data by date on a daily basis. Here's my split, and it just goes ahead and defines everything for you behind the covers. So I'm just going to go ahead and execute this. Now, because we scaled out, this will have disconnected. So I'm expecting the transport level error message first, and then re-execute just to reconnect and load the data from Azure storage blobs. Now, as I said before, what essentially this is doing is it's connecting out to the Azure storage blob itself. It's actually decompressing the gzip data, basically processing all of the structure and loading it into SQL Data Warehouse. And at the same time, it's distributing it based on round robin. Now, the way that works is it goes one record, one record, one record for each distribution, and so that it actually can guarantee that equal distribution. Now, this should be completing in any second. Interestingly enough, the first time you connect to Azure Storage Blobs, it takes roughly about an extra 20 seconds. If I run this a second time, it's cached all of that information and can actually execute against the storage blobs a lot quicker. And I will demonstrate that just to prove it. So there we go. It's loaded the 64,000 rows. Now that took 65 seconds, but as I said, because we had scaled out, essentially by the scale out process, we had restarted the server. If I now execute it again, all of that information around the external data is cached in memory and can actually execute the process a lot faster. Now, it's still going out to the Azure Storage Blob, pulling that data from there and processing it, but it's that first connection that it ever makes to these external sources that can actually take a little bit of time. And we saw the difference there. That was 3 seconds versus the 65 seconds. There's a substantial difference. And so when you actually come to write ETL processes, you'll notice that the first query might take a little bit extra time, and then from then on, it's a lot faster. Now, this is, for those that don't use Visual Studio and SQL Server data tools, this is the very latest Visual Studio 2015 with the most current SQL Server data tools. You require that to actually access SQL Data Warehouse. It's the only one today that understands what the SQL Data Warehouse is. And so essentially from here, you have things like external table tab that actually shows you all of the external table definitions that I have here. You can go down to the bottom to the external resources, and you can see data sources, file formats as they come back. These are the predefined ones, and I've got a number of different file formats there as I was testing earlier today. Now, so we can see here the stage direct marketing table. So if I just quickly look at the code, this will come back with the table definition. And from here, we can see it's just a normal table. So it's created. Now, you'll notice that there's no with clause there because the default is round robin. So if you forget the with clause within your create table statement, it'll automatically default to that. Now, I've actually loaded AdventureWorks as part of this. We always load AdventureWorks into SQL Data Warehouse. But this is a different version of AdventureWorks. This is one with 1 billion rows of data within the fact sales. Now, I've done nothing special here. It's just a clustered column store index, and it's hashed on online sales key. There's nothing special there. There's no partitioning. But we can just go ahead and we can count that data after we reconnect. And so that's just going out now. So it's actually accessing this table for the first time. So it's bringing all that clustered column store metadata into memory that it requires for the column segments. That's the first execution. And so from the first execution onwards, you'll see a dramatic difference in the performance. And you see this today with SQL 14 as well. It's always that metadata information that can take the length of time. But we saw 4 seconds, 1 second. It's still extremely quick at scanning that actual data. Now, don't take my word for it. We can do a lot more complex queries. And so this is just going out. We can joining a fact sales table to a date dimension. We're now doing aggregation. We're also doing an order by. Now this is across all of the 1,000 data warehouse units, all 10 compute nodes. So that took 10 seconds. There we can see the count coming back for each of the years. Now what I can show you is the explain plan. Now what you're seeing here is how SQL Data Warehouse is actually executing your query. So this in a XML format, so it's not quite user-friendly to actually look at, but you can see from here there's a number of different operations. So the first one being a broadcast move. And so it's noticing that you're looking at the date dimension. And to actually execute the query, the optimal way is to take that date data that you want and broadcast it or duplicate it between each compute node. And then directly after that, we do a shuffle move. Now this shuffle move is required because it's actually doing a redistribution based on the group by column. So in this case, calendar year. But it's actually applying the group by as part of that step. So this is pre-aggregation. So it's aggregating on the non-distributed data at each calendar year, aggregating that back up to roughly around the 10 rows that we saw, and then redistributing that 10 rows from each distribution based on calendar year to do the final aggregation step, which we will see here, which is the return. And we can see that the count has now become a sum. And that's doing the final step back to the client. So the return step is returning the data. Now, this table is distributed on online sales key. If I had distributed it on date key, I wouldn't have had to have done that redistribution. I wouldn't do that because it would be highly skewed, but that's how you actually have to think when you come to do your design. Is the best possible distribution is going to be on join columns. So if you have a fact table, a very large customer dimension, you would distribute your data on customer. So that join to the customer dimension is extremely fast. Any aggregation against customer is extremely fast without any data movement. And the only time it would need to move data is if you then change the aggregation or required to join to other large tables. So there are things that you can do within your actual design itself to optimize the execution. Any questions so far? I'm happy to modify this query just to prove out anything, just to show that it can run. Okay. So let's go back and just take a look at Data Factory. So Data Factory is one option to actually get data into SQL Data Warehouse. Now, looking at the author and deploy within here, what we've actually defined is a number of linked services. Now, when you look at new data store, you've got Azure SQL as an option. Azure SQL is SQL Database, SQL Server, SQL Data Warehouse. It's either of them. And so in this particular example here, it's defining the actual source as the data warehouse that we actually have, we was querying from. You can see, nice and simple, JSON structure. Everything is based on contracts, so you have to define what those sources are, what the file formats are. So in this particular case, I'll be loading Skybus data. And then you define what the pipeline is. Now, the pipeline here is just copying data. So it's literally copying the data from the Azure Storage Blobs into SQL Data Warehouse. Now, when it loads the data into SQL Data Warehouse, it's using BCP under the covers, or bulk copy. So SQL Data Warehouse fully supports the bulk copy protocol, so you can make use of that in your own applications as well. And just to show you what the diagram for that would be. So this is as simple as it gets when it comes to Azure Data Factory. It's just one individual pipeline copying the data from one table to the actual SQL Data Warehouse. Now, you would have seen within here that there was a number of other options for the data source. So SQL Server, Oracle, DB2, MySQL, Teradata, etc. That gives you the ability, so if you're using one of our competitor databases on-premise today, you can just literally reach out, connect to that via the data management gateway. ADF will handle all of that for you and pull the data into the SQL Data Warehouse. Now, this could be a straight table copy, you could define queries, you could define stored procedures. There are lots of different options that you have to actually get that data and to give you the flexibility that you need. And when it comes to defining pipelines, there's a number of different activities that we have here. So if you wanted to execute machine learning as part of your activity, it's as easily as adding a new activity to the pipeline that will allow that data to be pushed into Azure ML, processed, and have the data pulled out. So you can see that Azure Data Factory becomes your scheduling, orchestration, integration tool of choice for this solution. So one of the things that Azure SQL Data Warehouse is, it is essentially the central point of the Cortana Analytics Suite. Now, we see most people who would require the data warehouse first and then bring in the other components that form this particular view that we have on screen to actually ensure that their solution is, a fully end-to-end. So if I just quickly go through a couple of these, we mentioned Azure Data Factory, Azure Data Catalog, we're talking business glossary, metadata, the central place for all of your metadata across the entire platform. Event Hub, if you wanted to do real-time data loading into the SQL Data Warehouse, you can plug your data into the Event Hub today and have that data trickle-fed directly into the SQL Data Warehouse. And again, that could be from on-prem. It could be from Internet of Things. If you've got devices out in the field, you can automatically have that data go to the Event Hub. Azure Data Lake is another opportunity. So essentially, it's a storage layer for unstructured data, or any data, essentially. We actually use the Azure Data Lake internally today for Bing, for Xbox, for Nokia, for Skype. We have 3.3 exabytes worth of data on our own internal data lake, and we're increasing that volume by 300 petabytes a month. So we know that the platform scales. Now I know that's probably far extreme to the data that you have in New Zealand, but we know that we can manage whatever your requirements are. But think of the data lake as being the staging environment for your future cloud. Whatever data you have on-premise, you can pull into the data lake and then make use of by, say, SQL Data Warehouse, ML, Data Factory, etc. Or Hadoop is the other one. So machine learning, there's been lots of presentations this week on machine learning. But essentially, we have developed the Azure ML Studio, nice web interface with over 250 machine learning algorithms predefined for you to make use of. And if one of those algorithms don't fit your requirement, then you have the ability to write your own R script, your own Python script, and use that as part of the actual experiment itself. Azure HD Insight. So this is our Hadoop distribution. It's based on top of the Hortonworks data platform. And we see this as This will be moving forward from Windows to Linux in the future as we start to work closely with the open source community on the Hadoop platform. We also are moving to Linux to actually give us the ability to integrate better with some of the third-party tools out there for Hadoop as well. Azure Stream Analytics. If you've got data coming in that you want to do some form of real-time analytics, then the Azure Stream Analytics is actually the best service for this. SQL-based or SQL-like, so it's very popular with our SQL Server community. Now, yesterday we did some good demonstrations around the perceptual intelligence. So for those that actually attended, we did things like the facial recognition, speech recognition, textual analytics to come out with the semantics of that text. All of that was done live on stage with a few volunteers. But you can see that using something like that gives you the ability to say, well, I want to plug that into my data within the data warehouse. I want to make decisions based on that person as they walk into, say, a retail store. We identify that person is of age between 30 and 40, they're male, they're female, and then make a distinction on what they should actually be recommending to them. And that could all be fully automated. So we're definitely getting to the point where Minority Report is something that's going to happen, for those that know the film. Personal digital assistant, so the Cortana. Again, there was a demonstration done yesterday, about that basically gives you the ability to talk to Windows 10, ask it business intelligence questions, and for it to come back with the Power BI diagram, the chart, that actually shows you that data. And these you can then start to drill down literally just by using voice. And it becomes quite a powerful feature for business users that don't want to actually use the Power BI tool, for example. And of course, Power BI. Now, I've actually gone through this far faster than I was expecting. So is there any questions about SQL Data Warehouse that I can answer now? Yes?
How would you position using Data Factory versus SSIS using direct? Is there a latency velocity difference?
Is there a
velocity difference?
No, essentially it's using the same technology to extract data out of Oracle. The difference really comes down to how you develop, how it's actually executed, because it's done as a service rather than you maintaining your own SSIS instance. The other thing you can do as well is you can define what those the schedule increments are within Data Factory. So if you define it to be an hourly refresh, you can set it up so that there's particular columns within your source system and it'll automatically write the queries to get the data just for that hour. And so if there's anything that you want to go back, say for 3 hours, you can tell it to reprocess the past 3 hours and it'll essentially rewrite those queries for you automatically. So there's none of that reprocessing that you might have to have done in SSIS. So essentially, it's giving you a kind of framework as part of the package.
Matthew, how do we get started?
How do you get started? Good question, Miles. So today the Azure SQL Data Warehouse is in limited preview. Now, if you actually wanted to get onto that preview, please just stop by at the end of today or speak to Miles, if I'm sure you all know Miles. We'll just hand you an email address to send to, and we can get you onto that preview. It is as easy as that. Now, the preview itself, we expect to be running for another couple of months before we actually start getting into the GA period. Now, again, it depends entirely on what kind of things are found during the preview, but our GA expectations for SQL Data Warehouse is the first quarter of 2016.
Two questions. Firstly, how many DW users are you? And secondly, just elaborate on the SSIS question. SSIS is more than just taking data from source and dumping it into destination.
Yes.
How would you position some more advanced features that you sorting I can do on a database, nicer than in SSIS, but there's other features that I absolutely need to stick with SSIS.
Yeah.
How would I do that in Data Factory?
So the first question about how many DWUs. So in the preview, you can have up to 2,000 data warehouse units. So and when we go to GA, that will increase to 6,000. Now, essentially, that should be more than adequate for majority of the data within this room. For a balanced view, we say 1 terabyte of data per 100 data warehouse units. That's a balanced view of CPU per the amount of storage requirements. Now, that's actual data you're using. So everything within SQL Data Warehouse is compressed. So if you have a heap table, it's automatically page compressed for you. So we see 3 times compression. So 1 terabyte really is 3 terabyte on a heap table, or 5 terabytes on clustered column store, for example. The second question around SSIS. So yeah, SSIS has a lot more flexibility for doing transformations. So within ADF, you can do a lot of that. So you could, for example, call an SSIS package from ADF if you wanted to. It's one option. Another option is stored procedures. Third option is actually Hadoop jobs. So if you wanted to modify your SSIS to an actual Hadoop MapReduce job, for example, then you get the benefits of scale for doing that, because you can literally say within ADF, I'm going to instantiate this HD Insight cluster here with 10 compute nodes, process the data extremely quickly, and then drop it immediately afterwards, so you only pay for what you use.
Having just jumped into SSDT myself to handle our data warehouse on premise, is this going to be SSDT friendly, and does Azure Data Factory go into source control the same way?
Yes, great question. So the Azure SQL Data Warehouse is 100% SSDT friendly, in the sense that that is the recommended tool of choice for use against SQL Data Warehouse. Now, the one thing that doesn't exist today, and is something that's being worked at, is the automatic migration tools that's available within SSDT. Those are in play. So you could do things like, as you increase versions, you can modify tables automatically, etc. That's coming. I don't know the timeline for that. So the second question, sorry?
Oh, so it was basically the same for the Azure Data Factory was quite scripty.
Yes, so Azure Data Factory is available today in Visual Studio. So yeah, there's a Visual Studio plugin. You can use all the version control system of your choice within there. Very Git friendly for those that's using it.
So initially, put the database onto your data warehouse, would you backup and compress it?
So the question, can we do backup? So what I didn't actually mention here, and it's actually a great question, there are automatic backups as part of SQL Data Warehouse. So for those that know Azure SQL DB, we actually do backups every 4 hours. We are doing the same for SQL Data Warehouse. So from a SQL Server, so today, no. You can't take a SQL Server backup and restore it on SQL Data Warehouse. There is some effort that's required to actually modify the table structures. So we recommend that you export the data and then we actually have a tool, a migration assistant, that's coming as part of the public preview for SQL Data Warehouse that will actually help you take the SQL Server DDL and modify that to SQL Data Warehouse. Any other? Sorry.
So if you sign up for the data warehouse at 5,000 DWUs, which tools do you also need to buy? Data Factory comes with data tools for free?
So the question is, which tools do you have to buy? You don't have to buy anything, to be honest. It's entirely up to you. Now, that's not what Miles wants me to say, but essentially the SQL, you can use whatever tools you have today as long as it has the capability to load data, say via BCP. Now, we would recommend that you use these surrounding tools because they're all as a service tools. And so that will be your difference is, do you want to maintain what you have today, or do you actually want to move across to a managed service by Microsoft? It's if you wanted it to be a managed service, yes.
I think just the answer. You do need a monetary commitment to manage your usage on Azure. So if you're planning to use this for production, you will need to have something in place for the Azure consumption.
Yeah.
The end user is going to be buying will be the Azure.
Yeah. You need something in place to actually consume the credit, essentially. Any other questions? Okay. Thank you.